Okay, so this is problem 5.4, exercise 5.4. And in this exercise, we have an NMOS transistor operating at the edge of saturation. And when it says edge of saturation, it means this green curve here that I have highlighted in this plot. And it operates at a known V overdrive voltage, VOV, and a drain current ID. So those are two known values, quantities, right? And if we change the overdrive voltage to a new value that is 2 times the previous overdrive voltage, what's the new value of VDS and what's the new value of ID in respect to the previous one? Okay, so if we look at the curve VDS ID, the VDS curve, operating in the edge of saturation means that the drain source voltage is equals to the overdrive voltage. So if we want to keep operating in the edge of saturation with this new value of overdrive voltage, we need to increase VDS. So VDS new to be equals to 2 times the overdrive voltage that we had before, because then we stay in this curve here, this green curve here. Now, because we are changing the overdrive voltage, suppose the the first overdrive voltage is this voltage here, and we are increasing to this one here. So what happens to ID? Now, if you look at this curve here, we have ID2 for some known overdrive voltage. If we increase the overdrive voltage and keep working at the edge of the saturation, right, it means that we probably have to increase, we are going to increase the drain current, right? Now, how do we calculate by how much, what's the factor that this new drain current is increasing in respect to the previous one? So if we remember, in saturation, the drain current, so let me use a different color. So the drain current ID is half the process transconductance, Kn prime, times the aspect ratio times the overdrive voltage squared. So this basically means that the drain current is proportional, right? So it's proportional to VOV squared. Okay, so the square of the overdrive voltage. So if ID1, okay, is proportional to VOV squared, when we increase VOV by 2 times the current VOV, right, the overdrive voltage, it basically means that ID2 is going to be proportional to 2 VOV squared. And this means that the new drain current ID2 is going to be proportional to 4 times VOV squared. Now, if we take the ratio ID2 over ID1, it means that 4 VOV squared divided by, for the first current, drain current, VOV squared. So those two cancel, right? So let me, instead of using equals, use proportional. So we get this factor of 4 here. So the new drain current is going to be 4 times greater than the previous one. Okay, and we see that by basically looking at the behavior of this curve here. So it's a parabola, right? So basically for this particular transistor, it's going to be increasing by a factor of 4.